Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and this is my solution for homework lesson number 18. The course is by Paul McWhorter, and it's called Raspberry Pi Pico W. Paul does many different courses on electronic engineering. You can find him on YouTube at Paul McWhorter or at his website at www.toptechboy.com. Alright, enough promoting Paul, let's get to this. Alright, let's see. As you can see, we're going to, let me shut off that one. We're going to be making what Paul wanted us to do for the homework solution was 3 buttons controlling a RGB, and each time you push a button, it either turns on the red if it's a red button, blue if it's a blue button, green if it's a green button, and I even set it up to where if you push them again, they would shut them off. Alright, let's go to the schematics. Well, hold on, let's talk about this real quick. Okay, so we get the red. I had indicated it red for indicating the red button since there's no color on this schematic system. And then the green will be the green wire coming into the GPIO pin 14. The red actually went to GPIO pin 15, and GPIO pin 13 is blue. And they're grounded on the ground rail, and then the ground rail is also grounded to the RGB. Let's look at the coloring here. The wiring I come for the RGB. We got the red coming off of GPIO pin. I don't have this one memorized yet. Oh, yep. Well, of course, it'll be 16 because we've got 15 right here. GPIO pin 16 is coming across. It's going through a 333 ohm resistor and coming pick back up and going to the red leg of the anode leg of the RGB. And then pin 17 is green coming through a 333 ohm resistor, going to the anode leg of green. And then we got GPIO pin 18 will be going here to the blue, running through a 333 ohm resistor, coming to the anode blue leg, and it's grounded. The cathode leg of the RGB is grounded to the ground rail, and the ground rail is coming off of that'd be ground pin number 38. Pin number 38, ground for GPIO pin. Alright, let's go. For those who like to read schematics, here's a schematic layout. This is representing our Pico W, and you can see the pins I came out on, and it's running through the push button. I'm indicating a single instead of a double leg. Don't really need a second leg for this, so this one was a single. Then we come in through on also on the opposite side, the GPIO pins coming into the RGB. Alright, let's look at the code here. Let's bring up the code. And let's go up to the very beginning. This is for lesson number 18. We're importing machine, and class pin, importing time, library, and the class of sleep milliseconds. Declaring our globals. I know I could put this all in one line and have it run through, but I just haven't played with it enough that I don't feel confident with it enough. I just feel like that if I ever want to go back and change a pin, I would have to go through just kind of look through there and make sure I got it right. It's just because I just don't feel comfortable enough with it. I might do that next couple of videos. I think this is clean right here, so I'm going with this. Maybe in the future I might change. And you can see I got the pins laid out just like we talked about prior. But then here's something new. Paul had talked about this in the last video and also in the video number 18 about using a variable holding the status of our pushing of our button, which when you very first start up, it'd be considered a new button reading, which is 1, because that's what it's actually producing is 1, because we had put a 10, because we internal 10K resistor, which is actually be doing a pull up, which indicates that it's not allowing the current to flow through that button at the time, so it's reading 1. As soon as you push it down, then the current will flow through it, then it will read 0. So I established the new as 1, which it is, and in the old we went ahead and went with 1 to keep the light off until we push the button to record when the button's being pushed and not being pushed. And the LED status is false. Same thing goes with green and blue. Did my delay time for 100 milliseconds. excuse me. And then I created my objects of my all the colors, the red, green, blue of the LEDs, and the buttons of the red, green, blue button indicating. Ran a try and except with the keyboard interrupt to be able to shut off all the different colors of the RGB if we did hit stop. Then we did a true loop, went through a while loop indicating true, so it's going to be a continuous loop until we stop it. Or there's another exception that we wrote in, but we did not write in another exception, but that's how you could break out of a true, is by putting exceptions in it. Then we have our reading of our buttons declared as R new, our G new, and B new, as we declared up here also. And then we went ahead and did our first indication check to see if the red button had been pressed. If it's been pressed, we're going to change the status of the RGB LED to now be it is true, it is on. And then we're going to check the status of the green and blue, because I just want to be able to push the button and turn it off and not have the next button we push cause a bug which make that shut off before it comes on. This is just my solution to allowing the buttons to be able to be shut off by each individual button that you press. I'll explain a little bit easier when we show the demonstration here. And I did the same thing for the green and the blue, and then I printed out down here the status of what they are to be able to show. And then I had indicated the buttons to update from the old now indication would be down to new indication, so when we run through it here we can be able to cycle through that and verify our the if statement, the conditions, yes, thank you, the conditions. And then here's our accept. When we do a keyboard interrupt or hit the shut off down here as indicating the keyboard interrupt, it shuts everything off. Alright, enough of me talking and explaining about this. Let's actually turn it on. Let's show. There we go. Get the camera up above, hanging right up here. Alright, let's get this turned on here. There we go. Sorry. It gets confused sometimes. Alright, we're going to hit play. And we're going to come down here and we're going to show the buttons. This is indicating, even though I don't have colors that go on top of mine, I just set them up in order of red. In the middle is green, and on the far left, well, depending on how you look at that. Actually, when you're looking at it, it's left with my hands at, but it's right if you're looking at it through the camera. So on the far right will be blue, far left is red. So if I push it, you can see red comes on. Let's see here. Let's see if we can make that show up a little bit better. And stay out of my way so I can push other buttons. There we go. And then if I push the green, you can see the green it indicated. Well, hold on, I got a green. That button's not very good. I do apologize. You have to really press hard on that button. And then the green shows up. And then if I go to green or blue and I push on blue, blue shows up. And here's what I'm saying. I can switch button pushes, and they all come on. But if I press that same button again, it shuts off. And then if I go back to green, which that button is really messed up, it comes on, and if I hit that button again, it shuts off. Same thing with blue, and I can shut it off. That is pretty much it. If you have any questions or comments, leave them down below. And if you want to give me some words of encouragement to be able to start using functions or if statements inside a liner to make a one-liner, please leave a comment down below. And I've read about it, watched videos, I just don't feel very confident about it. Maybe you can give me some words of encouragement. Until next time, be safe out there, everyone. Figure out, there we go.